Hello, my name is Mohammad Arshad, and I joined PowerGrid in 2005. And I joined PowerGrid in 2005, and since then I'm working there. I have an experience of near about 17 years in HVDC. I have experience of HVDC engineering as well for 15 years, and the site experience also. So I did my BTech from NIT Allahabad, and then I joined PowerGrid. I have looked also the DMS department, distribution management services. So today we will discuss some. I would say some few things about HVDC because it is a very vast subject and a lot of time is required. And you know that in India, fortunately, we are having roughly I would say many types of HVDC, and recently you would be knowing that voltage source converter is also commissioned. So it is good for India that we are having various new technologies in the field of HVDC, and of course all these things are being done by the power grid. Today in the session we will discuss HVDC applications, advantages, disadvantages, and in the next section we will discuss some other things like installation, coordination, protection, and all that. Should I start? Hello?
Yes, sir. Yeah.
Are you getting my voice?
Yes, sir.
Yeah, please continue, sir.
Yes, sir.
Should I start the presentation?
Yes, sir.
Is it visible?
Yes, sir. Yes, sir.
Should I start? आपकी आवाज नहीं आ रही, क्लियर नहीं आ रही.
Yes, sir. Yes, sir. Yeah.
Okay. Today my topic is high voltage DC transmission. In this topic we will discuss why we are using HVDC. Apart from that we will discuss advantages and disadvantages also, and applications. If I compare why AC and DC, which mode of transmission should we use? So what are the limitations? What are the constraints? So we are just sharing like AC versus DC. Limitations of HVAC transmission, you know, reactive power loss. Reactive power loss, stability, current carrying capacity, Ferranti effect, solved by the HVDC transmission system. I think most of you aware that reactive power loss in the field of the AC transmission system is there. So my question, if someone knows, he can raise his hands. Reactive power loss. We can use a AC transmission system for transferring the power from the generating station to the load center, right? So anybody can tell that why we are using DC? Can raise the hand, and if it is possible. No one is there. Hello? Are you getting my voice?
Yes, sir. Yes, sir. Please.
Yes, sir.
Sir, please repeat the question. Hello.
Okay. So In an AC transmission system, as you increase the length, you know that the power transfer becoming difficult. Why it is becoming difficult? You know that as you increase the length of the transmission line, what will happen? Your inductance will increase. Because, hello?
Losses will be.
Everything is clear?
Yes, sir.
Yes, sir, but
Okay.
can you
Yes.
turn off your camera, sir? Maybe some bandwidth issue.
Oh, you want that camera should be off?
Yes, sir.
Okay, okay, no problem. It is good now, right? Is it okay?
Yes, sir. Now your voice is better.
Okay, okay. One moment, just one moment. Yes. So as you increase the length of the transmission line, what will happen? Your conductor length will increase. That length will cause the more inductance. As you increase the inductance, your reactive power absorption of the AC line will be more, right? So what will happen? If my line length is more, means my generating station is far away from the load center, we cannot use AC because at the sending end, what voltage you are using, you will not get the correct voltage level at the receiving end because your line length is more, your reactive power absorption will be more, so your voltage profile will not be flat and you will not get the correct voltage level at the receiving end. So what we can do, if I want power transmission through AC only, then what we can do? So for that we need to install many pumping station reactive so that they can pump the reactive power to the line so that we can have a flat voltage profile. But in this way, what will happen? Your cost will increase and many complexion will be there. So that is a problem that will be solved by the HVDC. In the case of DC, you know that in DC the frequency is 0. So the case of the inductance will not be there and the reactive power absorption by the DC line will be 0. I am saying reactive power absorption by the DC line. Please put stress on the DC line because I'm not saying the converter, I'm saying the DC line, right? We will discuss in the further slides. I am giving the stress. So your DC will solve the problem of the AC power which need reactive power. So stability, you know that in AC transmission system, we need transient stability and it is well before 50% of the whatever the maximum stability is there at you know that EV sine delta upon X. If I'm putting sine delta 1, then maximum power will be there. And our power which is being transmitted, it should be less than the 50% for the sake of the stability. So we cannot transfer the power if I want more power to be sent. Now the current carrying capability. Current carrying capability, what is the problem? In AC, you know that it is alternating current. Alternating current, what will have the effect? Alternating current will create magnetic field. And if you transfer more power, more environment area should be checked in the form of ROW, should be checked in the form of the nearby habitants, and also by the losses. In the case of AC, you see that Ferranti effect is also there. If your line is lightly loaded, then due to Ferranti effect, more reactive power from the capacitance, which is being between the line and the ground, that charging current will be more reactive power will be supplied, and the voltage will be more. So all these things will be solved by the DC transmission system. If anybody is having any problem, I will stop my presentation. I will first listen to what he is saying and what is his problem. Okay.
Hello.
Terminal. Yeah. Hello.
Hello, sir. Sir, please explain the effect on stability of the system by using HVDC and HVAC comparing.
Yeah. In AC, as I said, your stability limit should be less than the 50%. Then only your system will be stable. Means in the case of power transfer E into V, yeah, V1, V2 sine delta by X. Delta is the angle between the sending and receiving and voltage levels. If
Yes,
it is
sir.
1, then you will get the maximum power. Okay. But
Yes,
at
sir.
this maximum power, you cannot transmit the power. Why? If you go beyond that, or just due to any fault or due to any situation, it will hamper your stability. Your system will not be stable. So we would like to keep it less than 50%, means delta should be 30° or less. So our transient stability limit should be, margin should be there, and you have the scope so that in case of fault or any situations, your system may be stable. But in case of DC, we don't have such kind of limitations. We will discuss it further slide, how it is being taken care in DC. Okay. In the case of DC, as I said, if my line length is very much long, I cannot transmit my AC power. Why? Because it will need more reactive power support at the intermediate stations. Then only I can transfer. But that cost will be very much high. So I will go for the DC. But what happened in case of DC? You see that the purple line is the cost for the DC. It is the graph between the investment cost and the distance, right? So there is an offset on the y-axis. That is y-axis पे आप देखेंगे offset है. मैंने starting में वहाँ पर कुछ gap छोड़ रखा है. And there is a little bit offset for the AC cost, total AC cost. Then there is a intersection approximately at 600 to 800 kilometer. Beyond that, if you see that the DC cost is lower compared to AC cost. Below that intersection point, the AC system cost is well below the DC cost. We call that point is break-even point. Break-even point means if we transmit the power below break-even distance, the distance up to break-even point is called break-even distance. It will depend on manufacturer to manufacturer, designer to designer, and of course on the systems. It will vary between 600 to 800 kilometers. If my power has to be transmitted below this distance, so I will prefer AC system, considering a lot of other factors also. And if I want to transmit power greater than 800 kilometer distance, then I need DC system. In that case, DC cost will be less. Okay. This y-axis offset for the DC system is the DC terminal cost. DC terminal cost. Why? Because we need the converter equipment at the station, thyristor valves and converter transformers. Those equipments are very much costly. So the DC terminal cost is high compared to AC. AC terminal cost is lower because we don't have that thyristor valves converter, transformers, filters, and all that. So if my break even distance is 600 to 800 kilometer, then if I want to transmit power greater than 800 kilometer, then I will go for the DC system, right? Technical performance. If I'm talking about the technical performance, the DC transmission system has some positive features. These are mainly due to the fast controllability of power in DC line through converter control. As I told you that stability is good in DC system. Why? The controllability of power is very fast. We can control the current level, voltage level very fast. However, in case of AC, we cannot control the power. And the controllability of power is very fast in DC lines. So I can maintain my stability. Then full control over power transmitted. We will discuss in the coming slide that you know that there is a HVDC link between India and Bangladesh. It was commissioned in the year 2013 one block, and then in the 2016 second block. In that system, the AC power is being transmitted from the India side, and HVDC station is physically located in Bangladesh, Beramara position. Beramara city is there in Beramara, and from there they are getting the AC power. So if India is transmitting the power and Bangladesh is getting the power, so how can we raise the bill? If power is not controllable, I want to send 500 megawatt power, but they are getting 450 megawatt power, then there is a confusion. We can send the power through the AC also, but that power is not controllable. In DC system, we have a very fine control of the power. So we can raise the bill and get the revenue accordingly. This is the one advantage. The ability to enhance transient and dynamic stability in associated AC networks. You know that if there is a DC line and in parallel there is a AC line, if due to some limitations, my AC line is not loaded fully, or it is overloaded, I don't want both the case. Then in that case, if my DC link is there, so I can transfer the power to the DC system. It can be overloaded and it can be underloaded also. If I need more power on the AC line, I can reduce the power on the DC line because I can control the power in the DC link. So I can maintain that stability. Dynamic stability means if you know that there is sudden jerk of power in seconds, so it can be transferred to the DC also. My AC will be safe.